Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Neural Radiance Fields. NeRFs. Building 3D worlds from 2D photos. Imagine taking a bunch of regular photos of an object or a scene from different angles. Now, imagine a magic camera that could not only show you those photos but could also let you fly through the scene, view it from any angle you want, and even see what it would look like if you moved a bit to the left or right, even angles you never took a photo of. That's what neural radiance fields, or NeRFs, let us do. They turn a collection of 2D pictures into a living, breathing 3D scene that you can explore interactively. For developers, this means we can build incredibly realistic virtual environments, create stunning visual effects, or even generate assets for games, all starting from simple photographs. At its heart, NeRF takes multiple 2D images of a scene, along with information about where each photo was taken from, like a GPS for your camera, and uses them to construct a detailed 3D representation. Think of it like a skilled detective piecing together clues from various witnesses. Your photos. To build a complete mental picture of an event, your 3D scene, instead of storing a traditional 3D model, like a mesh of triangles, NeRF learns a function that can describe the color and stuffness, density, of every single point in 3D space. As developers, we're not just storing a fixed model, we're teaching a program to understand and recreate the 3D world on demand. The neural in NeRF comes from neural network, which is a core concept in AI. Don't let the fancy name scare you. For our purposes, think of a neural network as a super smart function or a very complex recipe book that can learn from examples. You give it ingredients, like a 3D coordinate, x, y, z, and a viewing direction, _x, _y, and it tries to give you a result, like the color and how transparent that spot is. It doesn't know the recipe initially, but by seeing thousands of examples from your input photos, it gradually figures out the rules. As a developer, you won't be writing these rules by hand. You'll be setting up the neural network structure and providing the data, letting the AI learn the complex physics of light and space. A radiance field sounds complex, but let's break it down. Imagine every single tiny point in a 3D space. A radiance field assigns two key things to each of these points. 1. Color. What color is this tiny point if you look at it from a specific direction? Think RGB values. Red, green, blue. 2. Density. How solid or see-through is this point? Is it part of an object, or is it empty space? So, the neural network from the previous slide learns to predict these two things for any given 3D coordinate and viewing angle. It's like having a tiny artist and a tiny material scientist at every single point in your 3D world, ready to tell you what's there and what it looks like. For developers, this means we're moving beyond simple textures to a more fundamental representation of light and matter. How do we teach this neural network to understand our 3D world? We feed it our input photos. 1. Input. For each pixel in each photo, we know its color, and we know exactly where in 3D space that pixel looks. A ray from the camera through that point. 2. Guessing. The NeRF neural network takes points along this ray and tries to guess their color and density. 3. Comparing. It then combines these guesses to form a predicted pixel color. This predicted color is compared to the actual color from the input photo. 4. Learning. If the guess is wrong, the neural network adjusts its internal recipe, its weights and biases, slightly to make a better guess next time. This process called optimization or training, repeats millions of times until the network becomes very good at predicting the correct colors and densities for the entire 3D scene, matching all your input photos. From a developer's perspective, this is the compute-heavy part, where our code orchestrates this massive learning process. Once our NeRF is trained and has learned the colors and densities of every point in our 3D space, the magic really happens. We can now generate new views from any camera position and angle, even ones we never provided photos for. 1. Virtual camera. You define a new virtual camera position and direction. 2. Raycasting. For each pixel in your new virtual image, we cast a ray. Imagine shining a laser beam from the camera through that pixel into the 3D scene. 3. Sampling. Along this ray, we query our trained neural network at many points to get their predicted colors and densities. 4. Compositing. We then use a technique called volume rendering to combine all these sampled colors and densities, much like how light passes through fog or colored glass, to determine the final color of that pixel. Repeat this for every pixel, and voila! You have a photorealistic image of your scene from a brand new perspective. Developers can build interactive viewers or export these new views for various applications. NeRFs open up a world of possibilities. Realistic 3D reconstruction. Create incredibly detailed and lifelike 3D models of real-world objects and environments from simple photos, far exceeding what traditional photogrammetry often achieves. Virtual and augmented reality. Build immersive digital twins of real places or objects for VR/AR experiences, making virtual environments feel truly present. Content creation. Generate high-quality 3D assets for games, films, or architectural visualizations without complex 3D modeling software. Robotics and autonomous systems. Help robots better understand their surroundings by creating highly accurate 3D maps. Democratizing 3D. Lower the barrier to entry for creating compelling 3D content. You just need a camera. For developers, this means new avenues for innovation. Whether you're building interactive web experiences, cutting-edge games, or powerful AI tools, NeRFs are a powerful example of how AI can bridge the gap between 2D and 3D, turning simple photos into dynamic, explorable environments, while the underlying math can be complex. As developers, we can leverage existing frameworks and libraries to start experimenting. Think about what you could rebuild in 3D just by taking a few photos. This is just the beginning of how AI is transforming our ability to create and interact with digital worlds. Dive in, explore the code, and start building your own 3D magic. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.